Men, and I use the term loosely, of course. The engine out of the Harton is on the operating table here, so to speak, on life support. We're going to do the repair job that I do to the countershaft bearing boss. And we're going to start with the left-hand side of the crankcase bolted down to the mill. And I'm going to center the mill on the trapdoor side of the countershaft. I've done this repair before, but I've done it differently, where I put a dummy shaft in this hole and then center on the dummy shaft. I think doing it this way is going to be a little quicker and more accurate. Just FYI, this case had a bunch of cracks around the primary screw holes that were blown out. They've all been fixed. They've all been welded in. I've had both sides of this crankcase on my surface plate with a big sheet of sandpaper, double-sided tape stuck to it, and I've flattened it off, no burrs, nothing sticking up. So we're going to center up on this hole, then we're going to bolt the other case to it and bore through the jacked up area. I got my LED edge finder chucked up. All right, I'm 0 on the Y. I'm going to lock down Y. Okay, Y is locked down. Let's get her centered up on the X. All right, we're centered with the LED indicator. I think I got a coax indicator I'm going to put in there and see if it reads out the same. I got my coax indicator plugged in there. Each graduation is 5/10 thousandths of an inch, so we're within certainly 10/10 thousandths, if not 5/10 thousandths of an inch on this hole. So the LED indicator, checking it, double checking with this, would appear to be just about right on. So the table's locked down. We're going to leave this where it is. I'm going to bolt the other half of the case on this half of the case and then bore it out. Well, I've made a couple of passes. The boring bar is pretty much centered on the hole. I've passed the point of no return. If I had a bearing cup to put in here, it would just fall right through. So, you know, there's no turning back now. The other day, when I redid these holes and tapped them and made the little cover plate, of course, that's all going away now. So I'll show you a couple of passes. I'm taking kind of light cuts, 20 thou per cut. So it's going to take a while. I don't have to be 100% accurate at this point because I'm machining for the big plug that's going to go in here. When I go back after I get the plug welded in and recenter on the hole on the other side on the trapdoor, that's the money one. That's the money shot. That's the one that's going to really count. So anyway, it's just a matter of hogging the material out. So let's hog some material out. This machine has an auto feed, which is really nice. And that's it, over and over again until I get this out to about, I don't know, 2.5 inches. When the edge of this hole starts to contact the inside of this larger boss over here, that's when I'm going to call it done. I'll bring you back when I'm near the end. All right, I'm probably, I don't know, 2/3 of the way to final size. The bulk of the material of the case is gone. This down here is that nasty weld you saw from the other side. So I'll show you. We'll do a couple of passes kind of out here in the middle so you can see what's going on. Hear the sound change? That's that nasty weld. I don't know what kind of rod that is, but the Harley crankcase was machining nicely. The weld, not so much. And because I don't want to be out here the rest of my life, I'm taking 40 thou each pass right now. Alright, this is getting very close to where I want it to be. Right here is the boss for the main shaft bearing race. I want to just kiss this a little bit. There's another piece of a boss back in here that I can barely see, and I know you can't, that I just want to kiss that. Underneath this, I'm beginning to see some voids down in here, which is not surprising. I may grind this all off and pass clean this up a little bit. I don't know. The other thing I noticed is that this surface here and the corresponding surface on the top of the engine are not flat nor parallel to each other. I may build this all up with weld and then come back in here and just face it all off to get it flat and parallel. But anyway, we're going to do a couple more shots over here, and we're getting pretty close to the end. So I bring you along for that. I've dropped down to taking 20 instead of 40. I'm just hitting this now. I think I'm going to take one more 20 thou pass and call it good to go. Alright, that's it. We're going to unbolt it, take a look at how we did on the inside, and make the insert for this. Very important, take the quill out of power feed, and we'll break it down and take a look inside. Yeah, not for the faint of heart. Do I think I can fix it? Fuck, I hope so. Bored the hole in here yesterday, cut out, the loose fitting boss, the bad welds on the other side, the 3 screw holes, you know, the whole works, got rid of all that. Today, cut out all of this area here, which is where them bogus welds were on the backside. I made this part right here that I'm going to weld into this thing. The crankcase is still on the mill. The mill hasn't moved. The 0 is retained in the DRO memory. So if it has moved, as long as I haven't unbolted the crankcase from it, I should be able to line right back up on it. After I get it welded in here, I'm going to, you know, take this corner off. And yeah, I think it's going to work. This area between this hole, and this edge was pretty thin. I was trying to build it back up, and as you could tell by the natty appearance of the weld, was having a hell of a time. I'll show you why that was, other than I suck as a welder. Okay, here's one of the reasons I was having a hard time. This is the inside area opposite of where I was trying to weld. And see all this brown shit in here? Well, there's a fucking crack and a void in here. And as I'm putting heat on the outside, this oil is being drawn up into the weld. And if you've welded aluminum, well, I didn't think to look at the inside while I was doing it. All I knew I was having a hard time. So I'd weld a little bit, grind the crud off, weld a little bit, grind the crud off, and you know I have decent penetration on the other side. It's not pretty, but I'm reasonably certain there's very few, if any, voids in it. But here's the problem. Right here is this crack. Oil was being drawn out of the crack into the area I was trying to weld. You can't weld over cracks, so I'm going to probably have to go back in here, grind this out, and try to weld inside the crankcase. Not my favorite thing to do. I might be able to get this though. I think I got most of the oil boiled out of it finally, and I should be able to get a bead like from here through the crack up to here. Anyway, that's what's going on the inside. Anyway, wish me luck. I'm not going to film the welding. It's hard welding to do. I got to get it right. I got one shot at it. I can't be monkeying with the camera while I'm trying to weld this shit. I'm getting ready to fill in this giant hole I made in the Harton crankcase. This is my dummy countershaft in there. And when I pop that washer on there, the dummy countershaft will be the same length as the real countershaft with the countershaft flow gear on it. This is the filler that I'm going to weld in there. These chamfers over here correspond to bosses on the inside where I'm going to mate up with the crankcase. This chamfer out here corresponds, of course, to this chamfer over here. I don't know if the camera will pick it up, but this metal over here is probably barely 1/4 of an inch thick, so it's not a strong area on the 900cc engines. But anyway, the purpose of that, having that washer in there, is it sets the height of the filler so that when I put the countershaft in, it'll have the correct amount of end play, more or less. I may have to adjust my shim a little bit. I've done a lot of these over the years, and I try to always refine the process. I used to center for this hole here off of the end of this dummy shaft. Well, the dummy shaft stuck up about another 3/4 of an inch, and it was in the way of getting my TIG torch in here when I had to weld this fillet. So I cut it off. The new method would have me centering off the countershaft bearing bore on the trapdoor, so I don't need to center off of this anymore. But this has been sandblasted, power washed, scrubbed in soap and water, washed with aluminum brightener, and I literally soaked this thing in acetone for about 3 hours, trying to get it as clean as I possibly can to weld. Let me show you why I did that. One of the things I did to this crankcase to get to this point was I built up the surfaces here where the sprocket cover bolts on because they were uneven and they were different height, they weren't level. Well, you could see there was an existing weld over here, okay? And as I was welding this up, and there was existing weld underneath here too, everywhere there was existing weld, and I put more weld bead on top of it, it had porosity. So the old weld right here came through to this area. Well, as I'm welding across this way, you know, the oil that was entrapped in the old weld came boiling to the surface. So anyway, that's why you got to clean these things. You got to clean them and clean them and clean them some more. You can almost never get rid of this. I had considerable problem on the primary side where I welded a bunch of small cracks with entrapped oil. So the other reason I soaked this thing in acetone for like 3 hours. But anyway, this is going to go in the oven. I'm going to preheat the whole mess. Pull it out of there, weld this up, take the trap door off, take the dummy shaft out, then go on the inside and get, there's area over here, an area over here, and an area over here where I could get some weld bead on there. So anyway, replacement part ready to go. Anyway, into the oven for preheating. While it's cooking, I'm going to cook myself some lunch. Here's the finished reinforcement from the inside. I've had the trans in and out of here many times, just checking and rechecking, setting the end play on the shafts, you know, making sure that my repair part was the right depth set into the transmission so I could get the end plates correct. Hopefully this will be the last time I see this. I'm going to stuff the trans in here in a few minutes, and that'll be done. One more thing I want to point out before I bolt the trans in there. This trans and this engine would have had the speedometer drive. When it blew up and was previously repaired, they welded the speedo drive up. And of course, this is the transmission countershaft low gear. And this gear would have had the spiral drive for the transmission out in this area. The spiral gear is actually a separate part. It is pressed onto a flange that used to stick out in this area. Well, of course, when you weld the hole up, depending on how you do it, you need to get rid of the spiral gear because there won't be room for it anymore. So you could press that off of the countershaft and then the flange will be sticking up. Well, you could walk that over to a grinder and just grind it all off to get rid of it to make the room that you need. And that's what the previous builder did, it looked like, because there was a little nubbin of the flange left and it was uneven and you could see the grind marks in it. Well, when I put the repair part in there, that hunk of flange sticking out was too long and was causing the countershaft to bind up. So I had to throw this on the lathe and trim some off. I could have used a grinder, I guess. But anyway, you could cut these gears to some extent. I don't know how much machining I could actually do on them, but this is what I used. A carbide bit, it had been broken, and I grind a very shallow angle with a very sharp point on it in the end, and it peels right through this gear, no sweat. The thrust washer is basically flush. It's just a couple of thou taller than the recess that it sits in. So the thrust gear makes contact with my repair part prior to the surface of the gear making contact with the repair part. And that will keep the gear from sawing through the crankcase. Just FYI, this if you weld your speedo drive up, depending on how you do it and how you make your repair parts, you may need to do a mod like this. And the other point of this being is, you know, if this trans ever goes bad in the future and a guy has to have work on it, you know, whoever works on it, if it isn't me, is going to have to be very careful. There's a lot of custom, one-of-a-kind stuff in here that is not going to be so easily replaceable. And enough yammering. Let's stuff the tranny in this thing now. You know, and here it is, stuffed in here. You know, this took a minute. What you're missing is the previous 10 or 15 hours of work, fitting, machining, welding the repair part in there, you know, and the whole setup. But anyway, that's it. Loosely, the Harton, got this all welded up. I haven't videoed the process. I've just been too busy to, you know, I'm a one-man operation here. All the mechanical work, the website, the YouTube, I do all the video, I do all the editing, I do all the building. It just gets to be very, very difficult to do all these things at once. And sometimes, you know, my focus is I have to build the engine. The video is really secondary. But anyway, got this all welded up, got the hole machined in where I needed it to be by lining up off the opposite side on the trapdoor. Very pleased. Very pleased. It all worked out pretty well. If this was too far apart, if this hole was too far away from that hole, you'd have problems. If it was too close to gears of bind, if it was off left or right, you'd have problems. But you know, the shaft spins pretty nicely. All the bearings fit in nicely. Very happy with this. But anyway, I'm going to put the motor together. Everything is test fit. The flywheels are together. They're test fit. Anyway, going to put it together. So I'll give you a little updates along the way. But anyway, welding done. Shafts test fit. Everything is good. And with that, I am out of here. Just a quick reminder, you can help support and grow this channel, first of all and most importantly, by hitting that subscribe button. So if you haven't subscribed already, go ahead and hit the subscribe button. If you'd like to do a little more, join me on Patreon. Links down below. So go ahead and join me on Patreon if you feel so inclined. And finally, coffee cups, stickers, and gas tank covers are available. This is a new design coffee cup. I like the old ones, but I like these new ones even better. Links will be provided in the description down below. Get yourself some. And thank you all ever so much for watching these videos. I really appreciate it. Bye.